Hi everyone, in this video I would like to go over Agentic AI and how to build Agentic AI applications. This presentation is really aimed at non-technical people, so you don't need to have any technical background in order to understand the following slides. It's just a presentation that I gave recently at Vlerik, which is a business school in Belgium. So yeah, if you don't know me, I'm Niels, I'm from Belgium and I studied business engineering and information systems engineering. It's a very long name, but it basically means business engineering with some more IT related courses. I did that at KU Leuven. And today I'm working actually for two different companies. One is ML6, which is a Belgian AI consultancy company implementing AI use cases, not only generative AI use cases, but also more traditional AI use cases for all kinds of companies in Belgium, the Netherlands, and Germany. We have offices in 3 cities, Ghent, which is the headquarters, but also in Amsterdam and in Berlin. And next to that, I'm also part of the open source team at Hugging Face, where I try to make AI models easier available for people in an open source way. So yeah, this is a bit of an overview of the content of this presentation. So basically we will build up agentic AI applications step by step by starting off with what is a large language model, and then we are going to make that large language model more powerful by augmenting it with certain tools. And then I will make the difference clear between building agentic workflows and fully autonomous agents, because there's an important difference between both. And finally, I'll discuss some use cases that we have implemented already for large companies here at ML6. But let's start off with the starting point of any agentic system, which is a large language model. So what is a large language model, or LLM for short? It's basically a zip file, or a sort of a compression of the entire internet, because these models are trained on basically all text that has ever been written on the World Wide Web. And so these models, let's assume for simplicity that they take text as an input and they produce text as an output. So the most famous example of an LLM is of course ChatGPT by OpenAI. But there are other LLMs as well, like for example Google has their own LLM series called Gemini. Anthropic is another company competing with OpenAI and Google, and they have their own LLM called Claude, and so on. And so all of these models, they are based on the original transformer model introduced and open sourced by Google in 2017 in the Attention is All You Need paper. And so as I said before, they can be seen as some kind of compression, some kind of zip file of the entire internet, because they have been exposed to all text that has ever been written on the internet. And so this allows you to then chat with these models. So you can just ask them certain questions, like for example, how are you? And in that case, ChatGPT will happily answer, I'm fine, and you? Anything you'd like me to help with, for example. So since these models have seen so many conversations on the internet, they are capable of generating answers that seem plausible. For example, if you just want to have a chat with it. So in those type of scenarios, it works fine. Another example is if you ask it to generate a recipe for pancakes, because models like ChatGPT have seen so many recipes of pancakes on the internet that they're able to memorize those kind of things in their weights, because a neural network like ChatGPT has what is called weights, which basically is that zip file which stores all of that knowledge, and then it can generate a plausible recipe to make pancakes. So for those type of things, it works well. However, where it gets a bit tricky is when you start to ask it questions that require more up-to-date information. Like for example, if I ask it, how many goals did Haaland, who is a striker at Manchester City, score this season? Then the LLM, as it's still a probabilistic model of language, it will still generate something that might seem plausible. Like in this case, it generated Haaland scored 33 goals, which is actually wrong. So this is what we call a hallucination. So the model hallucinates something, it makes up something that is actually not true, but it seems plausible, because LLMs, they're just probabilistic models of text, so you can still sample some answer from them, even though it's not true. And so this is, an artifact, you could say, of the fact that they are some kind of compression of the internet, but they are not necessarily a perfect redistribution of the internet. Another example is if you ask it certain arithmetic questions like dividing one number by another. Again, these LLMs, they are probabilistic models of text, so they will still generate something that might seem plausible, but it's, again, a hallucination. It's something that is entirely made up and is wrong. And so you could say that this zip file of the entire internet is some kind of lossy compression, because yes, some information might still be in that brain of the LLM, like recipes for pancakes, but for things where you actually want an exact answer, they actually fail. And so for those type of things, we can actually make them more powerful. And this is where I come to the Augmented LLM, which is a more powerful LLM, because what we can do is we can augment these LLMs with one or more tools. And so tools can be anything. They can be, for example, a search engine like Google. And this allows these LLMs to then appropriately answer questions that require real-time information. Like if you, again, would ask it the question, how many goals did Haaland score this season? And you equip the LLM with the Google search engine tool, then what it could do is just basically perform a reasoning like, okay, and this question requires a Google search, so it will then perform it Google search, and then it gets a certain answer, and then it can use that to present the answer in natural language to the user. So in this case, it will then generate Haaland scored 19 goals so far, which is the appropriate answer. Another example is, so for the arithmetic questions, we could equip or augment the LLM with a calculator tool. And in that case, the LLM is intelligent enough to know, okay, in case I get a question of one number divided by another one, I can just use the calculator tool to first get the answer from it and then present it in natural language to the user. So in that case, again, we can solve these type of arithmetic questions. But so, as I said before, tools can be anything. So they could be a Google search engine, they could be a calculator, but they could also, for example, be a certain API, which is an application programming interface to some kind of software system, like in this case, a weather API, which means that if someone asks what's the weather like in Paris, then the LLM could just perform a call to the weather API and then present the response to the user. So these are just some examples of how we can make an LLM more powerful by augmenting it with one or more tools. And so, as I said, one or more tools, you can also, of course, add multiple tools at once to an LLM. And in that case, like let's say in this case, we equip the LLM with a search engine tool, so Google Search, a calculator, and then also the calendar API. In that case, we can just ask to the model, for example, what's on my calendar on June the 15th. And in that case, basically these LLMs themselves, they are intelligent enough to know, based on the type of question, which tool to use. Of course, this again requires some prompt engineering, because in the prompt you will basically then say you're an assistant and you have access to these 3 tools. And then you also can give some examples in your prompt. But based on that alone, the LLM is capable of calling the appropriate tool and making use of it. So in this case, it knows, based on this type of question, I don't need Google Search or the calculator. I can just use the calendar API to then fetch the information from that and, for example, then respond that you have a concert planned on that day. And so this is a bit how these augmented LLMs work. And so they are what you could say the basic building block of any kind of agentic AI system. Any kind of agent is definitely an LLM that has been equipped with one or more tools. And so, once we have such an augmented LLM, such a large language model that has been equipped with multiple tools, we can build agentic workflows. And so here I want to make an important distinction between building agentic workflows and then fully autonomous agents, which I will come to in a bit. But so what do we mean by an agentic workflow? It's basically some kind of pipeline, some kind of flow where we still, as a human, define the individual steps, and then we will use these augmented LLMs, which are indicated here by the green boxes, in each of those steps. But so, a workflow is something where we still define a predefined path ourselves, and then we will use these augmented LLMs in one or multiple steps of the workflow. So here I just give an example of such a workflow, which has been taken from the blog post from Anthropic, which I will link in a bit. And then you can build agentic systems. So to give a concrete example of this, and this is actually an agentic application that ML6 has built, is a fashion garments generation system. So it's a system that can actually just generate new types of clothes for a fashion collection. So we built this as an agentic workflow. So it means that it's not just one LLM that is autonomously operating. Instead, what we did was we defined a workflow, some kind of pipeline, where in each of the steps we will involve one or more LLMs. So in this case, we have a first step in the pipeline where we use an LLM to summarize trend reports. And so in this case, it might be an LLM that has, for example, access to the Google search tool, and then it can perform certain Google searches to find, okay, what are the current trends in the fashion world, what might be, for example, colors that are currently popular, and then it will try to summarize those. So that's like the first step of the pipeline. So it can, for example, fetch various kind of PDFs from the internet, all kinds of trend reports, and then summarize those. Once we have done that, we pass that to a second step, which is another LLM call, where it takes in those trends, those summarized trends, and it will generate what is called mood boards. So mood boards are kind of an inspiration deck where other people can then actually start to design clothes from. So yeah, that's also what we do, because then in the third step, once we have created the mood boards by the second LLM, we have a third LLM which will then take in that mood board, and it will then generate textual descriptions of fashion garments. And so yeah, it will first generate those as text, but then it's also been equipped with a text-to-image tool, which in this case is DALL-E 3, which is a text-to-image generation model from OpenAI, to basically visualize those garments and those clothing items. And then finally, once we have generated those clothing pieces, we have another LLM step, another augmented LLM, you could say, which is actually a vision language model in this case, because then it will take in those pictures of those clothing items together with the descriptions, and it will provide consumer feedback on those. So basically mimicking what potential consumers of those type of items would say about that. And so once we have incorporated that feedback, so yeah, that final step could actually be a loop where, based on the feedback, the previous LLM then generates other clothing items, and again, some feedback is being generated. Then we actually end up with some garments, some fashion items that have been entirely AI generated using this agentic workflow. And so this is just one example of an agentic workflow that we built. But so yeah, the important thing here is that we are still in a driver's seat, like it's still us determining how we are invoking LLMs and involving them in each of the steps. So it's not just one LLM or one AI model that has just been given the task, please generate some fashion garments for me, and then it performs autonomously, because that would be like a fully autonomous agent. The reason why we at ML6 are still focusing mostly on workflows is because to give them full freedom, like these LLMs, it might quickly get wrong and turn into chaos, because these LLMs themselves, they are not that powerful yet. We need to guide them, and this is why we are using these LLMs in each of the steps of a predefined path. So another example, this is again taken from the Anthropic blog post, is a routing system where you might, for example, first have an LLM that gets the input from the user and then needs to decide, based on the user question, to which other LLM can I forward this. So we also implemented something like this as a workflow for a chatbot use case. So this is for a large bank in Belgium, where we also built a similar system where, based on the user question, we will first have an LLM that will classify it, and then we'll basically forward it or route it to one of the 3 potential LLMs, each tasked with a certain objective. So one LLM could be, for example, an appointment agent, you could call it. So it's an LLM that can schedule appointments. So it might have access to certain tools to actually schedule appointments, for example, a calendar API to then actually register the appointments in a calendar. Then we have a second LLM which can give you information about loans. So this could actually be a LLM that has access, for example, to a retrieval database. So it could be like a RAG type of LLM, which is augmented with a retrieval database to find information about loans from the bank. And then a third LLM could be an unblocking LLM which can help people unblock cards. So again, you could augment this type of LLM with certain APIs that it can help people unblock cards. And so if then someone asks a question like, for example, I want to make an appointment, what is then going to happen is the first LLM, the routing LLM, is going to forward that to the scheduling appointments LLM. And from that moment on, the user is basically talking to that LLM, and then it might generate the answer, sure, could you give me your name? Because it will need that in order to perform the tool call to the appointment API, for example. So this is just another example of where we still define the workflow, and it's not just one LLM doing all tasks at once. So it's just to still have some control over how the flow is going. But so I can contrast this type of agentic workflows with a truly autonomous agent, because there are already some examples of those. So what do we mean by that? Well, typically it's an augmented LLM in a loop, which can act fully autonomously. So you give it a certain task, and the LLM itself is equipped with one or more of these tools. Could be Google Search, could be another browser, search engine, could be a calculator, and so on. And then it will basically autonomously do some reasoning, decide which tool do I need to use. Then it will actually use that tool. So this is what we call an action. Then it will receive some results, and then it will continue performing its reasoning. And so there are already multiple examples. Here I want to make it very concrete. This is actually something that might end up in, for example, the Google Home Assistant. I saw that Amazon, for example, recently launched their Alexa Plus variant, which is probably going to have a system that looks very similar to what is being shown here, because it's an example of a true autonomous agent where we have an LLM equipped with one or more tools. But the Google Home Assistant for now does not have this LLM behind the scenes, but I'm pretty sure Google is working on that. So let's say you're in your house and you want to ask your Google Home speaker, please play that song from Titanic on Spotify. So what Google is then going to have is an LLM. So it will be Gemini, and it will be equipped with multiple tools. It might have access to Google Search, it might have access to the Spotify API and so on, so that it can actually play music. And so what is going to happen in this case, if someone asks about that song from Titanic and to be played on Spotify, well, the first thing is it will perform some kind of reasoning. So in this case, it looks at this question. Okay, I have this question from a user. I have access to Google Search and Spotify. So as I don't know the song of Titanic, I will first use the Google Search tool to find the appropriate title and artist of that song. So then it's going to use the Google Search tool, and it's going to provide as an argument Titanic song, and then it's going to get some response. So in this case, it might get Celine Dion, My Heart Will Go On, which is the most known song from that movie. And then, as a next step, again, it will perform some reasoning. So, so now it has the title and the artist of that song. So now, I have access to the Spotify tool, so I can probably use it to then play it. So then, the next step is just the LLM performing a tool call to the Spotify API and provide as arguments title is My Heart Will Go On and the artist is Celine Dion. And then hopefully, if the LLM is smart enough, it will end up with actual music being played on your speakers. And so this is just a very simple illustration of how these fully autonomous agents work. In this case, for a home assistant use case, like Siri, Alexa, and Google Home are. Well, at least Siri, for example, and Google Home aren't yet, but they will be in a few months. Then, there are multiple other examples of such fully autonomous systems. For example, Deep Research is a very popular one, originally created by Google, but now replicated and made more powerful by other companies like OpenAI, XAI, which has their own LLM called Grok, Perplexity, and so on. And there are other fully autonomous agentic systems, so I can just showcase some examples of them. One that I also use a lot myself is the Cursor agent. So Cursor is a tool, is a software program that you can download, and it includes an agent that you can just program autonomously. So you can just say, for example, I have this software bug, can you please just code it for me? And then it basically goes on its own, and it starts editing files, it starts writing new files, it starts running, executing actual code, but there's still a human involved here in the loop, so you still need to confirm when the agent wants to actually execute something, and then you end up with a pull request. In this case, it's quite a funny pull request because it wants to replace the OpenAI model from by a Claude model from Anthropic. But so it can fully autonomously code for you to implement a certain feature or fix a certain bug. And so we can map this to our figure. Because in this case, we could give it the task, hey, please fix this software bug. And then the LLM that's being used, in this case, in the case of Cursor, is Claude Sonnet 3.7, which is currently a quite popular LLM for agentic use cases. It's one of the best, especially for coding. And in this case, we equip the Claude Sonnet model with two tools. Could be Visual Studio Code, which is the IDE, the software program that is used to actually write code. So in this way, the LM is actually allowed to write files and edit files, and we also give it access to the terminal, which is a bit more low level, which is like the actual program where you can execute commands and run code. And based on that, it can just write certain files, then execute them, get feedback, see, for example, a certain bug that is still occurring, and then in that loop, it will still try to fix that problem for you. I have to say I'm quite satisfied with Cursor Agent. It's a very powerful tool and allows me to code way faster. It also writes at least 50% of the code for me. Another example of such a truly autonomous agent is Grok Deep Research. So as I said before, there are multiple players out there already implementing a deep research variant, which was originally invented at Google. And in this case, I asked Grok Deep Research to list me the 5 best companies in Belgium to implement the generative AI use case. So let's say I want to build a RAG chatbot and I'm in Belgium, so I want to know what are the best 5 companies that can help me with that, and can you please also list their strengths and their number of employees for me. So if you then hit enter, it will just start autonomously. So in this case, again, it's a LLM that has been equipped with a search engine. It might be Google, it might be another one. I don't think it's Google in this case, because Grok has been developed by XAI, which is a company from Elon Musk, and I'm not sure they can just use Google search. And as you can see, it starts seeing ML6 in its results. And based on that, it goes on. As you can see, it has already processed nearly 90 web pages. And then let me scroll a bit in the video. So then, it starts summarizing what it has found. In this case, for example, it found some companies. it also includes ML6, which is interesting to see. And so then it will also list the strengths, the employee count, how relevant they are for building a RAG chatbot, and so on. And so it does this fully autonomously in just a matter of some minutes. So this is quite amazing, of course, to see that it can come up with like a whole report and has done full research on which companies are most relevant for building a generative AI use case. And we can again map that to the figure. So in this case, the LLM is not an OpenAI model or Claude Sonnet 3.7. In this case, it's Grok, the LLM developed by XAI, and you can give it a certain task like list me the 5 best Gen AI companies in Belgium, and then equipped with a search engine like Google Search, it can just autonomously research the topic, gather more information from different web pages, summarize that, and then go on in a loop until it comes up with a certain report. Then another and final example of such a truly agentic system is Manus AI. It's quite a popular trending example from last week. It's been developed by a Chinese company. And what this can do, it can do a lot of stuff. But one example here is someone asked to create a comprehensive Tesla stock analysis dashboard. So someone just asked, okay, I want to know more about Tesla stock. Can you please generate a comprehensive dashboard for me? And this agent also can control a computer screen. So as you can see, it's also starting to code. So it has also access to the terminal, which is this program which allows it to execute commands. And then it goes on and on until finally it comes up with a dashboard, as you can see. A full dashboard explaining a summary of what it thinks, how Tesla is currently doing in the market, whether or not it's worth investing in them, and so on. So this is another example of such a truly autonomous agent. Again, we can map it to this figure. It has actually been leaked that Manus AI is actually just Claude Sonnet with access to 29 different tools. So they equip it with quite a bunch of tools, including the browser, so it can actually control a browser and just go on Google and find related things. It also has access to a coding environment, so it has access to the terminal or VS Code, where you can actually write code and execute that. And this allows you to just ask, for example, to generate a detailed report of Tesla stock, and then it just goes on in that loop fully autonomously. So another nice example of such an autonomous system. But so this has been integrated like in various kinds of products, as you can see in the previous slides. So these are some examples of such agents, but as I said before, they are typically integrated in some narrow scope, like for example researching a topic and generating a report out of it. Whereas at ML6 we mainly focus on building those agentic workflows, those predefined paths where we involve LLMs into each of the steps. And then you can make this even more powerful by going to a multi-agent system. So a single LLM that has been equipped with one or more tools is what we call a single agent architecture. But you could of course also have multiple of these LLMs, each with their own tools equipped, and then let them talk to each other and have them make some kind of collaboration. And in that case we describe that as a multi-agent system. So you could arrange these agents, these multi-agent systems, in various ways. Like one could be a circular way of organizing them. Another one could be just having a supervisor agent, or what is also called a manager agent, and then have multiple agents below that in some kind of hierarchical structure. There are multiple ways you can get quite creative with this. So an example here could be that you have one agent overseeing all the other agents, one agent having access to DuckDuckGo, which is a search engine similar to Google search. Then you could have another trend analysis agent, and so on. So each of them equipped with certain tools and being responsible for certain tasks. So this is also something that we are building because I can now move on to some use cases that we have built and that can be seen as multi-agent systems. So one example is the fashion engine that I talked about before. So again, remember that we had this pipeline or this workflow where we involve LLMs in each of the steps. In this case, we actually already see some of the outputs of this whole workflow. So it comes up with certain garments together with the description and so on. And then, we have another LLM actually that then groups those items together in collections, or what is called here micro drops. So it will basically then, have a look at like all the items that have been generated before, and then it will try to group them in some kind of logical way, which make up a collection. And then it will also generate a certain description for those collections. And then finally, you can also have another LLM call. So this is another step in our workflow where we then create marketing material for it. So this is an LLM that then takes in the collections or the micro drops and will then generate marketing material for it. So this LLM is only responsible for generating marketing material. So this is an example of such a use case. Another example of an agentic workflow that we built. This is, I think, another video, because as I said before, we first have this LLM that summarizes all the trends in the market. So this is actually the first step of the pipeline. Once we have gathered the relevant trends in the market, we have another LLM that will then generate a mood board. As you can see, these are the mood boards that are then being generated, and there's also still a human involved in the loop here, which can then select the mood board that he or she likes the most, and then based on that, the other steps of the pipeline are being executed based on that. So this is a pretty cool use case. Another example is the recruiting agent. This one I would say is more of a single agent use case, because there's only one LLM involved that has been equipped with the task of performing an interview with a person, and it's a voice use case, so it's actually all done via voice, but it's still a workflow, because we are still, as humans, defining how a conversation should go. So we basically have defined certain states of the conversation, and then we move the LLM from one state to the other. So for example, in first state, the LLM needs to ask, how are you, what's your background? And then, for example, in the second step, it needs to ask, do you have a driving license, for example. So let us have a quick listen to it.
AI assistant working with XYZ HR. Is now a good time to talk?
Yes, that's fine. So this is actually just me talking to the agent, the voice agent.
Great. I'm calling because you applied for the barman student position in the Tongeren area. This will be a short, informal chat lasting no more than 5 minutes. Are you ready to start?
Yes, I'm ready.
Perfect. First question. Why are you interested in the barman student position in Tongeren?
Well, so basically at ML6 we have defined like a predefined workflow where we basically, depending on the vacancy, we define a certain amount of steps that the LLM needs to traverse, and then we basically ensure that the conversation is always going in a certain direction that we want. So this is still why it's not a truly autonomous agent, because it's not just one LLM that is running in loop. No, it's rather us still defining a manual workflow of steps, and then we move the LLM from one step to the other. So in this case, for example, it first asked me about why I'm interested in this position. I'm a student right now, and I need some more money for partying, which is why I was thinking of combining this job with my studies.
What specifically interests you about working in an Italian restaurant?
So first of all, I love to work as a bartender. I already have some experience regarding that. And also I love the Italian cuisine. So I thought this could be like the perfect combination of both worlds.
what do you think are the most important skills or qualities for a barman?
Yeah, so it goes on. And so we basically will always only move the LLM from one step to the other in the workflow once it has collected the appropriate information. For example, if it first needs to collect the name and the age, then we will prompt the LLM to always still ask and gather that information before we move it on to the next state. So this is another example of a agentic workflow. A final example that I want to give is the virtual tumor board, which is a medical use case. So in this case, it's a multi-agent system again, where we have multiple LLMs, multiple augmented LLMs, because each of them has been augmented with multiple tools. Like we have a cell therapy agent, which is an LLM equipped with certain research databases related to cell therapy. We have another agent, the genetic agent, which has been equipped with research databases regarding genetic research and so on. Then we have an immune agent, so this is an LLM representing research regarding immune systems. And then finally we also have a clinical trial agent. And actually there's also a fifth LLM involved here, which we call the moderator. So this could be seen as some kind of supervisor or manager agent, which is then making sure that the conversation between those LLMs is going in a smooth way. And so the way this system works is someone comes in with a certain symptom of a certain disease, and then we basically have these LLMs talk to each other. So each of them has been equipped with certain tools. So then they move on and have certain conversation where they'll propose certain things based on their personal research, and then finally we hopefully end up with certain output advice for the patients. So yeah, we also have a video on this. I'm going to skip a bit because the first part I already explained, and then let's move on to the actual conversation between the agents.
Let's see how a discussion could look. You can read the patient's use case description at the top of the screen. The cellular therapy expert queries its knowledge base for treatments that might suit the patient's profile and suggests a selection of treatments. The virtual expert subsequently asks the others for their opinion. Next, the genetics expert responds elaborately, citing papers that support this opinion. The immune treatment expert lists valuable insights from the discussion and includes some relevant statistics. The experts discuss and question each other on the proposed treatments. They can make use of various tools, such as querying their academic knowledge base for relevant information. The conversation continues until the experts have resolved the discussion points and reached mutual agreement. After the debate has completed, we can generate a report that summarizes the experts' insights and lists.
Yeah, so this is another LLM call that then will generate a summary of the entire conversation with the topics that have been discussed between those different agents, and then some potential treatments that they discussed.
The suggested treatment plans. Finally, we link the suggested treatments to possible corresponding clinical trials based on each treatment and the patient's profile. This demo illustrates a multi-agent conversational methodology where LLMs are invoked to actively view and present a topic from.
Of course, this was just a demo. It's meant for demo purposes, but it just showcases the potential of how you can build very powerful multi-agent systems where you basically have different LLMs having different personas representing different topics, and each of them equipped with different tools so that they can collaboratively solve a certain problem.
What you're going to see is a conversation.
And then a final slide here is just a blog post that I highly recommend if you ever want to build effective agentic systems. It's a blog post from Anthropic where I also took some figures from for this slideshow, where they basically go over their experience, their learnings, which they had when building agents for different companies across different industries. One of the key points they make in there is so that distinction between workflows, which is like still a pipeline where you have a predefined path of certain steps where you involve the LLMs in each or one of the steps, and then you have fully autonomous agents where they run in a loop and do everything autonomously. And an important point they also make in there is like not just trying to use agents because you want to use agents. Make sure to really go through like whether it's really necessary to use an agent or build an agent, and whether a simpler system might not be easier to implement, as they say over here as well. And then a final thing that I also recommend, this is also something that we adopt at ML6, is that we try to avoid frameworks as much as possible, because they add a lot of abstractions and they make it hard for you to debug your application, even though it's nice to take inspiration from them. But typically we just work with the LLM APIs directly, rather than working with one of these frameworks, even though, as I said, they're nice for inspiration purposes. Alright, so this was all for me. I hope you learned something about building agentic AI systems, and see you in the next